Hey everyone, welcome back. Today we're going to be diving into something pretty wild.
Yeah.
China's push into thorium-fueled molten salt reactors. Thorium, you heard that right?
Yeah, these aren't your typical nuclear reactors, right?
Yeah.
With molten salt reactors, the fuel is actually dissolved
Oh, wow.
in liquid salt,
Okay.
which creates a system with some pretty unique characteristics.
So China wants to have a working thorium reactor by 2025.
Yeah, that's right around the corner.
It's just around the corner.
Yeah.
We're basing this deep dive on an IE Spectrum article,
Okay.
all about China's project, and we've also got some excerpts
Right.
from a document simply titled China.pdf to add a little extra spice to the mix.
What makes this even more intriguing are the potential implications.
Oh, yeah.
We're talking energy independence for China, possible link to their rare earth mining.
Wow.
And of course, we can't ignore the elephant in the room.
Right.
The proliferation concerns that come with thorium.
All right, let's break this down.
Yeah.
First up, China's thorium project. What's the latest?
Well, this isn't just theoretical for China.
Right.
They already successfully completed a 2-megawatt experimental thorium reactor.
Wow.
Back in 2021.
Okay.
It was a proof of concept.
Okay.
And now they're scaling things up to build a much larger reactor.
So they're serious about this.
Absolutely.
Does this put them ahead of everyone else?
Absolutely. China's efforts are putting them at the forefront of both thorium fuel breeding and molten salt reactor technology.
Wow.
There are other companies around the world exploring this, but none have actually operated a molten salt reactor using thorium.
You know, this reminds me of that documentary I saw about nuclear power.
Yeah.
I realized I knew next to nothing about it all.
Right.
So help me out here. Didn't the U.S. experiment with a molten salt reactor a while back?
You're right.
Yeah.
The Oak Ridge National Laboratory did run a molten salt reactor experiment, but they used uranium, not thorium.
Okay.
Plus, it was shut down back in 1969. There were technical issues,
Right.
but funding cuts played a role too.
Mm-hmm.
The Cold War was shifting focus at the time.
Yeah.
So China's project is really pushing boundaries in several ways.
This is where I get curious. Why thorium?
Yeah.
Why go with this specific fuel source?
Well, there are a few compelling reasons.
Okay.
First off, thorium is abundant in China's Gansu province.
Okay.
That's a big deal for them.
Mm-hmm.
It could mean energy independence by reducing their reliance on uranium imports.
Okay, so they're thinking long-term, aiming for self-sufficiency.
Right.
Can't blame them for that, especially in the world today.
Exactly.
But is that the only reason?
Not at all.
Okay.
Think of it as a two birds, one stone situation.
Okay.
Thorium is also a byproduct of their existing rare earth mining industry.
Wow.
So they're essentially extracting a valuable energy source while they're already mining something else they need.
Oh, wow.
Talk about efficiency.
Yeah.
And this gives China a significant strategic advantage. They could control a large portion of both rare earth elements and a next-generation fuel source. It's a power play with huge global implications.
I'm starting to see why this is such a big deal, but let's talk about the elephant in the room. The whole proliferation issue.
Right.
We're talking about nuclear material here, bro.
Yeah. Yeah.
How worried should we be?
This is a crucial point we can't gloss over.
Okay.
The risk of proliferation associated with thorium is very real.
Okay, so break it down for me. What makes it so risky?
When thorium is transformed into uranium-233,
Okay.
it becomes directly usable in nuclear weapons.
Oh, wow.
That's the danger zone.
Yeah.
Think of it like this. It's not just about energy.
Right.
We're talking about the ingredients for the most dangerous weapons imaginable, potentially falling into the wrong hands.
So it's not thorium itself that's the issue, but what it can be turned into.
Exactly.
That's right.
And to understand the gravity of this, I'll quote Edwin Lyman, a nuclear expert. He said, "It's of a quality comparable to separated plutonium."
Yeah.
That's a serious statement.
Wow, that really puts things into perspective.
Yeah.
But if it's so dangerous, why are countries even considering thorium reactors?
Right.
What are they hoping to achieve?
It's a paradox, right?
Yeah.
The potential benefits are huge, but so are the risks.
Yeah.
Despite these concerns, many countries, including the US, UK, Japan, and even India, are exploring thorium reactors.
So it's a balancing act, weighing those potential rewards against some very real dangers.
Exactly.
But is China the only one pushing for this?
Not at all.
Okay.
This is becoming a global race with high stakes.
Wow.
Even Google has partnered with a company that's building a uranium-based molten salt reactor to power It's data centers.
Wow.
So the interest in this technology is clearly growing fast.
Speaking of different elements, I remember seeing a periodic table highlighting thorium, uranium, and plutonium.
Sure.
It really helped me visualize what we're talking about.
Absolutely. We're talking about some of the heaviest, most complex elements out there,
Yeah.
each with its own unique properties and challenges.
So we've got this global interest, potential energy independence
Yeah.
for China, and some serious proliferation concerns. This is a lot to process.
It is.
Where do we go from here?
If we connect all of this to the bigger picture, we're looking at a potential energy paradigm shift.
Okay.
Imagine a world where thorium, not uranium, is the dominant nuclear fuel.
Okay, now my mind is really blown. What would that world even look like?
It's hard to say for sure, but
Yeah.
the implications are huge.
Yeah.
Geopolitically, the balance of power could shift as countries with abundant thorium reserves gain a strategic advantage.
So we're not just talking about energy, we're talking about global power dynamics.
Exactly.
Resource control.
Yeah.
This has ripple effects across the board.
Absolutely.
But hold on a second. Isn't the thorium is a cleaner argument? Bit of a smokescreen?
Yeah.
I mean, doesn't mining and processing thorium still create environmental hazards?
That's a great question, and you're right.
Yeah.
It's not a simple solution.
Right.
Thorium mining and processing do have environmental impacts,
Yeah.
just like any large-scale industrial activity.
Right.
The question is whether those impacts are less severe than those associated with uranium mining and traditional nuclear power.
Okay.
And remember, we're talking about the potential for less long-lived radioactive waste
Right.
compared to traditional uranium reactors.
Gotcha.
It's a complex trade-off.
So there's no easy answer there.
Right.
But going back to China for a second,
Yeah.
are they really doing this for environmental reasons? I mean, their track record isn't exactly stellar.
That's a healthy dose of skepticism.
Yeah.
And it's important to consider their motivations. It's likely a mix of factors.
Right.
Energy independence, economic competitiveness, strategic advantage,
Yeah.
and perhaps even some genuine concern for the environment.
Okay.
It's hard to know for sure what's driving their decisions.
Speaking of global competition,
Yeah.
this leads us to another fascinating aspect of the thorium story.
Okay.
Several other countries are exploring thorium reactors, right?
Exactly.
What are they hoping to achieve?
Exactly. While China might be leading the charge, they're not alone. The US, UK, Japan, and India are all researching and developing thorium reactor technology.
Oh.
Some are motivated by energy security, others by the desire to reduce carbon emissions,
Okay.
and still others by the potential for technological leadership.
Right.
It's a complex mix of national interests.
So it's a global race, but not everyone is convinced that thorium is the answer. Denmark's Copenhagen Atomics, for example,
Right.
they're working on a thorium-based molten-salt reactor design
Yes,
that they believe can mitigate the proliferation risk.
that's right.
Are there any other potential solutions being explored?
Absolutely. Researchers around the world are exploring various approaches to address the proliferation concerns.
Okay.
One promising avenue is the development of proliferation-resistant reactor designs, which aim to make it more difficult to extract weapons-usable material from the fuel cycle.
Right.
Another approach is to focus on international cooperation and safeguards to ensure that thorium technology is used responsibly and peacefully.
This whole conversation really makes you think, doesn't it?
It does.
What would a world powered by thorium actually look like?
Right.
What would it mean for the global balance of power?
Yeah.
And for the environment?
These are the questions we need to be grappling with.
Yeah.
There are no easy answers, but understanding the complexities of this issue is crucial for making informed decisions about our energy future.
You've given us a lot to think about.
I hope so.
This is definitely a topic that deserves further exploration.
Absolutely.
And who knows, maybe one day we'll look back at this deep dive as a pivotal moment in our understanding of the thorium revolution.
Yeah, I like that.
But we hope this deep dive has sparked your curiosity and given you some food for thought.
Remember, the future of energy is being written right now, and understanding the choices we make today will shape the world we inherit tomorrow.
That's a powerful thought to end on.
Yeah.
But before we wrap things up completely, I'm curious about one more thing. We've talked a lot about the potential benefits and risks of thorium. But what about the economics of it all? Is thorium energy actually cost competitive?
That's a key question, and the answer isn't so straightforward.
Right.
The economics of thorium energy are still somewhat uncertain,
Okay.
as we don't yet have any large-scale commercial thorium reactors operating.
Yeah.
However, proponents argue that thorium could be significantly cheaper than traditional nuclear power in the long run,
Okay.
due to its abundance, high energy density, and potentially lower waste disposal costs.
So it's a bit of a gamble, right?
Yeah,
Countries are investing in this technology without knowing for sure if it'll pay off economically.
that's true. There's definitely an element of risk involved,
Right.
but that's often the case with emerging technologies.
Yeah.
It's a bet on the future with potentially huge rewards if it succeeds.
This has been an incredible deep dive.
Yeah, it has.
I feel like we've only scratched the surface of the thorium story.
That's the beauty of these deep dives.
Right.
They're just the beginning of the exploration.
Yeah.
And with a topic as complex and multifaceted as this, there's always more to discover.
So to leave our listener with something to ponder, what's one key takeaway you'd want them to walk away with?
I'd say this. China's thorium gamble is a fascinating case study in technological advancement, energy security, and global power dynamics. It's a high-stakes game with potentially transformative consequences, both positive and negative.
That's a great way to sum it up. It's not just about the technology itself, but about the ripple effects it could have on the world stage.
Precisely.
Ah.
And it highlights the importance of informed decision-making, considering all angles before embracing a potentially revolutionary technology.
Well said. We hope this deep dive has equipped you with the knowledge and insights to follow this unfolding story. Keep an eye on China's progress. Stay informed about the global implications, and never stop asking questions.
Remember, the future of energy is being written right now, and understanding the choices we make today will shape the world we inherit tomorrow.
That's a powerful thought to end on. Until next time, keep diving deep.